let's solve this problem. As you see in this figure, we have 3 objects, M0 on horizontal surface, frictionless surface, smooth surface, and it was attached with the help of massless rope or string and connected to this kind of system, M1 and M2. So first of all, we need to draw free body diagram for each object. For M0, it's very simple. Downward we have its weight M0G. Upward we have a reaction force, let's call it N0, and we have a tension force, let's call it T0. So from this free body diagram, we understand that this object can move only to the left. It has only one choice. There is no any other variants. There is no any other choices. So let's say it will move to the left with acceleration A0. It will move. It cannot stop. It cannot be at rest because there is no friction. So according to the Newton's second law, tension 0 equal to mass 0 times acceleration 0. So we are 100% sure about this equation. Any questions about this part? No, very simple, as you see. Now let's come to the other 2 objects. And again, let's draw free body diagram. For the first one, we have a M1G downward. Upward, we have a T1. Let's call it T1. And we don't know in what direction it will move. Yes? So let's assume it will move downward with acceleration A1. So Newton's second law for object M1 will be or can be written in this form. Weight M1G minus tension upward will be equal to what? M1 A1. Let's call it second equation. Now let's come to the free body diagram for the second object. Very simple. Downward we have M2G. Upward we have what kind of tension? T2. But we can call it immediately T1 because pulley, this block, has no mass. So it's simple. Here we will have same T1. And in what direction it will move? Also unknown, actually. Why? Because this is a complex system. Maybe it will move upward according to the pulley, but since M0 is moving to the left, according to for someone who is watching outside, it may move downward. So let's call A2 and let's assume it will be moving downward. Okay? So Newton's second law for this object will be downward we have M2G minus T1 equal to M2A2. And let's number it equation formula 3. Now we need to think about these 3 equations. Do we have enough equations to solve A1, or do we need more formulas, more equations? So we need to discuss. This part is very important. So let's start here. Which one is unknown? T0 is unknown, yes. A0 unknown, A1, A2, and the T1. So 5 unknowns basically. But we know that T0 actually equal to what? To T1. Why? Because of this pulley. The movable pulley has no mass. So according to the second law of Newton, total force acting on the movable pulley should be equal to 0. So upward we have a T0, downward we have a T1 and a T1. So T0 should be equal to 2 times T1. So this will be our equation number 4. Equation number 4. So basically we have a 4 equations. 4 equations, but 5 unknowns, yes? So in terms of mass, we cannot solve this problem. We need one more equation, one more formula. So what might be this formula, this equation? Newton's second law, we apply it for 4 objects basically, M0, M1, M2 for the movable pulley, and we have these 4 equations. We cannot apply Newton's second law anymore because we don't have any objects, extra objects. What else we can do? So we can decrease number of equations. Let me use equation number 4 and let me take it and replace with T0 here. So basically we will have 3 equations. So let me rewrite the equation number 1. It will be 2T1 equal to M0A0. So this will be our equation number 5. So basically we have active 3 equations. Equation numbers 2, equation number 3, equation number 5. So now we have only 3 equations and we have 4 unknowns. A0 unknown, A1 unknown, A2 unknown, and T1. Still we have 4 unknowns, 3 formulas. So now let's try to find the relationship between 3 accelerations. In order to do this one, I need to draw again this system, but I will draw only M1 and the M2 because we already know the acceleration of the movable pulley, which is A0. That is enough for us. We don't need to consider any more object M0. So be careful, watch carefully. I will draw and I will try to find the relationship between accelerations. So I will basically zoom this part. Movable pulley. Here we have M2. Here we have M1 at the beginning. To keep it simple, I will not draw these boxes. I will just call it dot. This is M2. This is M1 to make it simple. Okay? This is at the beginning. So the length of this part, let me call it L2. The length of the rope at this part, let me call it L1. It's unknown, but it's not equal to 0. And the rope here, the length of the rope here on the pulley, let me call it L0. Okay? So the total length of rope here will be equal to L1 plus L2 plus L0. This is the total length of the rope. Okay? It's very simple. Now, after some time, the position of these 3 objects, M1, M2, and pulley, will be different because they are moving. So, pulley will be here, approximately. M2 will be here. M1 will be here. Okay? Now, what is the length of the rope here? Of course, again L. It will not change. But I will rewrite it in terms of mass. What is the length of the rope at left side? What is the new length of the rope at the left side? Let me assume that this pulley moves downward for distance x0. And this x0 actually equal to 1 over 2 a0 t square. Let me assume the left side of the rope moves downward for distance x2. And this x2 logically will be equal to 1 over 2 a2 t square. Okay? Because initial velocity of the system equal to 0. And the right side of the rope or object m1 moves downward for distance x1. Again, x1 will be equal to 1 over 2 a1 t square. Okay? So what is the new length of the rope at the left side? So I will try to draw. So this is a new length basically, yes? Which is equal to L2. This is L2 at the left side initially. The upper part of the rope moves downward for x0, yes? The down part moves downward for x2. So this is the length of the rope at the left side. Same logic I will use for the right side. And of course plus L0. L0 didn't change. Yes? The length of the rope on the pulley. Now let's come to the length of the rope at the right side. Initially it was L1. Upper part moves downward x0, yes? Plus x1 because the length of the rope, the end, right end, goes downward. This should be equal to again L. So basically this equation, this part should be equal to this one, yes? So we can remove L1, we can remove L2, we can remove L0. So at the left side we have a 0, at the right side we have a minus x0, minus 2x0, plus x2 plus x1 equal to 0. Or we can say x1 plus x2 equal to 2x0. Or it means a1 plus a2 equal to 2 times a0. So now let me copy our main equations. So we have m1g minus t1 equal to m1a1. This is equation number 2. And equation number 3, m2g minus t1 equal to m2a2. And we know that 2t1 equal to m0a0. And finally, a1 plus a2 equal to 2a0. So now we have 4 equations and 4 unknowns. Let me check again. T1 unknown, a0, a1, a2. 4 unknowns. We have finally 4 equations. Further, it's totally mass. We can solve it. So let me do in this way. From the equation number 1, let me take a1. So a1 equal to m1g minus t1 over m1. This is a1. a2 from the second equation, m2g minus t1 divided by m2. And from third equation, a0 equal to 2t1 over m0. So I will use all these 3 expressions, 3 equations. I will use it in last equation. So basically, a1 comes here, a2 comes here, and a0. So it's totally mass. Carefully, we should solve this one. So m1g minus t1 over m1. This is a1 plus a2. This is a2 should be equal to 2 times 2 t1 m0. This is a0. That's all. So we found tension 1, and we can use this tension to calculate a1. So this is final answer for A1. So now some students asked one question. M1, how we can know that M1 moving upward or downward? So answer is here. Basically, you need to pay attention to this part. If M0, M1 plus 4M1, M2 minus M0, M2, if this part is greater than 0, it means it will be moving downward. Because we assume that it will be it's moving downward. If this expression has less than 0, it means we will have negative A1. It means it will be moving upward. At the moment, we don't know the value for masses, so we need to leave as it is.